Okay, for your experiment, you're doing something with bicarbonate of soda, sodium bicarbonate, baking soda, whatever you want to call it. You've got 3 different jars, and you want to know if you have enough. Well, what you need to do is basically this. You need to convert all to the same unit. How did I do this? Well, I said I took 454 grams plus 350 grams and got 804 grams. This particular problem, I'm not so worried about significant figures. So I'll let the 350 slide and use this number. I then need to convert to kilograms. That's what my other units are. So I will take 804 grams times the fact there is 1 kilogram per every 10 to the third grams and get 0.804 kilograms. To know if I have enough, I'm actually saying if I take what I have less what I need, I should have greater than or equal to 0. That's basically what I'm saying. This is what you're kind of thinking in your head if you're trying to figure out if you have enough. So what am I going to do? I'm going to take this 0.804 plus the 250 they said I had in this other container. I'm going to add those, and then I'm going to subtract 1.20. If I add these two together, don't I get 1.054 kilograms minus 1.20 kilograms? And that is not greater than or equal to 0. I do believe I am short 0.146 kilograms. So no. Again, we're just trying to formalize what you would be doing in your head. If I'm doing this problem, I've got 3 different containers. I need to add the masses up in each container of stuff I have. And then what I'm trying to do is say, this is how much I need, this is how much I have. I need to take how much I have, subtract what I need. And if it works, if I have enough to do the experiment, the answer has to be greater than or equal to 0. Reasonable? Or at least as long as I'm explaining it, it's reasonable. The minute I disappear, it starts to look unreasonable again. Okay. Then, volume in SI units. Kind of moving on. A thing we need to know. You need to put this in your head. 1 centimeter cubed equals 1 milliliter for volume. This tends to be a dry weight. So like if I were looking at crystals or sand or something like that, I would tend to do it in cubic centimeters. This tends to be a liquid measure, a fluid measure. So if I'm measuring air, or I'm measuring water, or I'm measuring medicine. You may have remembered hearing in old medical shows where they talk about give them 50 cc's of Thorazine or something, or epinephrine or whatever. cc stands for cubic centimeter. Cubic centimeter. Centimeter cubed. So they have that, if you listen to those shows, like they're trying to save the guy that's having a heart attack. They're always giving him like an epi shot or some sort of, whatever they call that. What do you, words. But that's what, you need to have this to do some of these problems we're going to get to. So looking at the problem. So taking a look at this, we should now be here. So volume in SI units. Volume is a measure of the three dimensions of an object, length, width, and height. Okay? Unit 1 cubic centimeter is equal to 1 milliliter. Keep that in mind. So if we have a box that is 12 centimeters by 25 centimeters by 15 centimeters, length is supposed to, in general, be the longest measure. The other's height depends on how it's setting. And the same thing with width, depends on how things are setting. If we took this box and did the calculation and got it in correct significant digits, we'd have 4,500 cubic centimeters. Well, we want to convert from cubic centimeters to milliliters. It's pretty simple. It's a one-to-one relationship. Then we need to get to liters, which is the 1 to 1,000. So we do all those conversions, and we get to the fact that box should be 4.5 liters. Two significant figures, again, because the 1 milliliter, 1 cubic centimeter, and 1 liter is 1,000 milliliters are exact. So then we want to look at problem number 8 here, and we want to work through it together. So that's where I'm at now, and that's where we'll end up. Just enough time to fit that in. So, we have that. So that's where I'm at right now. This gets a little more complex. It's still the same type of problem. It just gets a little more complex. So as I do this, we want to know the volume in liters of a box that measures 1 by 2 by 5. Could you guys fit in a 1 by 2 by 5 box? In meters, this is 1 meter. Okay, I can stand up in a 2 meter box easily. And if it's 1 meter wide by 5 meters long and 2 meters high, all of you could fit into that box pretty easily. So just keep that kind of dimension in mind. So I've got 1 by 2 by 5. Convert the volume into cubic centimeters. That says, well, first, what should I do? All my measurements are in meters. I probably want to convert my measurement in meters to centimeters. If I want cubic centimeters as an answer, I probably want to be in centimeters. So I've got 1 meter times the fact there's 1 centimeter per 10 to the minus 2 meters times 2 meters times 1 centimeter per 10 to the minus 2 meters times 5 meters times 1 centimeter per 10 to the minus 2 meters. Pretty simple. I get 100 centimeters, I get 200 centimeters, I get 500 centimeters if I do the math. I multiply them all together and get, well, this is essentially 1 times 10 to the second, 2 times 10 to the second, 5 times 10 to the second. I would get 10 times 10 to the sixth cubic centimeters. Or cubic centimeters, or in correct scientific notation, 1 times 10 to the 7 cubic centimeters. That's what I'm looking at. So first, I converted this is my step to convert to centimeters. Now, for those of you that are a little more comfortable with your math, you could have simply done this. 1 meter times 2 meters times 5 meters times the quantity 1 centimeter per 10 to the minus 2 meters quantity cubed. Mathematically, that's the same and maybe a little simpler. So I get this, 10 million. Conversion factor from cubic centimeters to milliliters. I have that 1 cubic centimeter equals 1 milliliter. If I'm converting from this to this, my conversion factor is going to be 1 milliliter per 1 centimeter cubed. Giving me 1 times 10 to the 7 cubic, or 1 times 10 to the 7 milliliters. Then I want to get to liters. That's my standard measure of volume. Well, I take that number, the 1 times 10 to the 7 milliliters, and I convert to liters. Milliliters in the denominator, liters on top. It is 10 to the minus 3 liters per every milliliter. Units, I got liters. Awesome, because milliliters cancels. Coefficient is still 1. Power becomes 10 to the positive 4. Or, that's correct scientific notation and everything, no changing needed. Or it could simply be 10,000 liters. So then, your big homework. Try 9, 10, and 11. Assume tomorrow we'll go over it just like this. Questions, confusions? Not until you get to try. Okay, hopefully the video worked. And if you need to see more of what I just did or see it done slower, you should be able to get to the video, give me a couple of class periods because I need to get it uploaded for you. But I should have just recorded all of that. I hope. Okay, any other questions? Okay, you guys have a great day. Thanks for playing. Awesome. I'm glad I was able to help you, Bryn.